Hello friends, welcome back to my shop. It's Sunday morning. I gotta prep some pens for ship out, so I'm gonna do that right now. And we're gonna go over foam cutting. We're gonna go over cooler stuff later in this video, but this is the non-sexy stuff, so let's start with it. So, firstly, apologize if the noise is driving you crazy. I'm printing a bunch of shallower bins for kind of organizing my pens. They're gonna go into a case, but so the machine's just cranking out pens, and I have to do shipping, and that's such is life. So hopefully the audio isn't too bad. Basically, since day one, since like order 3 or order 4, I started shipping my pens in these little boxes, and that has made life easier because they always arrive like perfect, no damage at all. The only annoying bit is I have to essentially die cut the foam that goes in there, and I've tried like drag knifing it. I've tried different. The foam is so soft. The problem is I can't CNC cut it. I can't CNC drag knife it very easily because like these knives go through it, but even then it's just too much. It's annoying. So to solve this issue, I actually purchased a laser cutter. I should have a laser cutter coming in like, I don't know, the next week or two, and that should make this process much easier. But I may as well show you the old method that I've done for the last forever amount of orders, because it's worked. It's not perfect, and that's why I got the laser cutter, so I can do some more fancy things, as well as better branding on my boxes, because a printed label and stuff is cool, but and like a kind of sticker on the bottom, I don't like it. I want to do it better, and the laser cutter will let me put the whole box in, and I can do all the graphics on the box, branding, whatnot, and I can cut all this foam and remove a step that I have to do manually because I don't like this part. This is the only part of making pens that I don't enjoy. But it has to be perfect because it's like the first thing that the customer sees. And if you open a package, like if you open your phone, like your phone package, you know how much money goes into packaging phones? Like tons, because it makes it look better. I could just as easily wrap pens up in newspaper and toss them in a Ziploc bag and send them to people, but it just doesn't convey the same level of quality. So it's important, and I want to make it better. Anyways, this is the old method. So, I think we fixed the problem. This is the part, but I don't hit myself in the face with it. It's basically 4 or 40 TPI threads on a custom OD. And I had it in the machine and cut it once with the 30 passes. And then I just reran the program like 4 or 5 times just to see if it would maintain. I didn't think index on this machine would pick up correctly because I have 2 magnets that go past the hall sensor to create the index for the threading. They're north-south orientated, and I thought the switch or the logic would just pick either a high or low transition, but it looks like it always picks a high transition, which means as long as I don't move the workpiece in the collet, I can go back and recut threads. I mean, I'm cutting air, I'm not cutting anything, but it worked perfect for this purpose because I could run the code over and over and over and over and over to see if there was anything mechanically that was causing the weird cutting through my thread crests. I also ran the lathe at twice the speed I would normally thread at, just to put a little more load on all the steppers, because now it's running at very close to its maximum speed, and steppers get weaker the faster they spin, so that would have made it worse. And it passed perfectly. Like I said, it ran like 120 odd passes over it, and not a single issue. So I think it was my flanked infeed method spitting out a fusion, something was just not jiving. So I'm going to run that next, and if I recreate the error, I know what the problem is, and I know how to fix it. So that's a win. So I think I have it figured. I ran a bunch of tests in brass, and the threads came out perfectly. So the next thing to do would be run it in titanium, and I did that. Where Where are you? Where are you? There we go. And it came out perfect. Threads are 40 TPI at my OD that I want. All the other turning is perfect. The internal bores are perfect. The little ink sits, I'll show that in a minute, perfect. And I even I machined just the brass mating piece to test it, and fits in perfectly. I have to undercut the body still a little bit so this fully seats. And I might also put an O-ring in here because when things go south with fountain pens, it gets really messy. So I'd like to have double O-rings if just the thread seal isn't enough to keep any mishaps from ruining pants and shirts. So my goal was to fit the pen into a 3/8 body. Couldn't quite do it. I got it down to 0.4, which is pretty good, which means I can't use standard size stock. So I have some 1/2 inch rod here that I'll turn down to fit the body and the cap, and I'll do a pocket clip, and we'll be done. This will be able to go onto its new owner, and they can field test it for me and report back with things they find. I've already connected it up to an ink. I'll show you. So this is the nib grip feeder tube assembly. I don't know what I'm going to call it. And that's obviously where the body screws onto the back of this pen. And there'll be a cap that screws on it as well with a pocket clip, so it sits nicely in your pocket. Obviously, I will cut down the body so it's not so massive. And we'll turn it down to size as well so it's not 1/2 inch. But this pen is designed around the Pilot Metropolitan nib feeder assembly. And you actually get this weird little cleaning reservoir thing with the pen. And you also get this kind of proprietary ink refill with the stock Metropolitan when you buy it. So I've been using this for testing. Obviously, no one would want to use this kind of converter or this kind of reservoir on this pen because it's proprietary. You want to use your own ink. I had planned to make my own reservoir on the back, like a lever style or a piston style or something, but those are more complicated to make than I thought they were. So I went with this is a Con 40. This is a screw type converter. These are very, very easy to get. I bought a 3-pack actually just to experiment with. And this little stepped turning on the back is just so that this lines up nicely. And then when this fully seats, it makes a nice tight seal. Then you can basically put the nib into your ink, suck it up like that, and you're off to the races. The cool thing with a screw converter is no matter which way you screw it, it never gets longer or shorter. It's all internal. It's a double thread, so it's kind of neat actually. I was pretty impressed with the engineering that went into this. Be very difficult to make. Not very difficult, but it'd just be a lot to make it. Take me much longer. So I'm gonna go with this one. And then if you break it, these are very economical to buy. I think they're like $8 or something like that. So get another one of those. The little ball bearings inside are just to agitate the ink to keep everything nice and happy. But yeah, I am very, very happy with how that turned out. I got to do some final polishing yet. Take off any of the edges that bug your fingers. I'd like to put a little flare on here to kind of stop your fingers from sliding off the end of the pen. But I also want to keep it inside the smallest body I can possibly get it in. And I don't have enough metal here. If I make the flare bigger, I have to make the threads bigger, which makes the body bigger. So you're chasing your tail at that point. So I'll settle with this. The nib just pops out. I'll pop it out. Why not? Or else I'm just spouting lies. So nib just pops out, whole feeder assembly comes out, and you can clean everything. And this is just a straight through piece. Oddly enough, this piece, if I was smart, I would have just bought carbide drills or regular drills of the size I need and drilled right to size. With titanium, or at least in my experience with titanium, I usually drill out bulk of the material and then I'll come in with a boring bar and clean up the rest of it. The only issue with this is the boring bar I had to make to get deep enough into this pen to do the internal bore, but it's a little bit too flexy, which means it rubs. And when you rub with titanium, you work harden it. So I actually work hardened the inside of this tube while I was working on it, which basically means you're not cutting it anymore. Not without carbide, and most of my drills are high-speed steel, so that did not work. So what I ended up doing is I actually put my tool post grinder on the lathe and I ground the inside to the 2 dimensions I need, which are just very slightly different on the feeder tube here. It's this one and this one. And I just wanted to have a nice seat on both of those. So I ground the inside of this. I wouldn't obviously do that normally because that That's tedious, but once I already put so much work into this, I didn't want to scrap another one of these. So I ground the inside, which gives you an immaculate finish, but it's just not conducive to production. Thankfully, I'm just building the one right now, so I am very happy with that. That's the hard part. With the titanium out of the way, now it's just brass turning. I did the threading in the brass, which was the, I guess, next hard part, and I'm happy that it turned out perfectly. So we'll finish it up. We'll bore the body or turn the body down to size, get it all packed up and sent along its merry way, and then we can move on and carry forward with the other projects I got going on here. To add even more spice to the mix, my laser cutter came in. I'll put video here. It's a K40, nothing fancy. It's like the cheapest laser cutter you can get. I basically bought it for the tube and the high voltage supply. Everything else, I don't really care about. The steel box, I'm probably going to reuse, but everything else is going to be gutted because it's not the highest quality unit, but you get what you pay for. So it's dirt cheap by comparison. I actually had a fancier laser cutter picked out initially. I can't justify the cost right now for what I intend to use it for. If this turns out to be worthwhile, I can buy a nicer one down the road. But this lets me cut my teeth for a very, very, very small amount of cash outlay. So I'm excited about that. I got the extrusions already ordered, and they should be here tomorrow to do the full retrofit on that. Like I said, I'm changing the whole motion system out. We're going to make it actually have a usable work area instead of like the stupidly tiny work area it has. And yeah, another tool to add to my arsenal, which will make the foam cutting and the cardboard cutting, it makes so much easier. I don't have to sit there with my knife anymore and do that. So I'm pumped about that. That's all I got for this week. I will see you guys again next week. Take care. Bye.